Hello everyone, myself Arvahita, Assistant Professor of CSE Department from Rohini College of Engineering and Technology. I'm here to explain a few concepts in the subject CS 8592 Object Oriented Analysis and Design. I'm here to explain the topic state machine diagram and when to use the state diagrams. The objective is to learn about the concepts of the state machine diagram and modeling and when to use these state diagrams. First, let us know what are the UML state machine diagrams. A state machine diagram shows the life cycle of an object, what events it experiences, its transitions, and the states it's been between these events. The transition are shown as arrows labeled with their event. States are shown in rounded rectangles. Okay, so this is an example for telephone book. So when a telephone comes, it will be in the idle state first. It will then start, that is, it will on hook, that it enters into the active state. Okay, so first it will be in the idle state. When the telephone rings or connection comes, it will come to a state on hook, that is on call. Then it will become an active state. So this is the example for state machine diagram. So this is the initial state, start state, and we'll have an end state. Therefore, we can create a state machine diagram that describes the life cycle of an object at arbitrarily simple or complex level of detail, depending on our needs. Now let us know about what are called events, what are called states and transitions. An event is a significant or noteworthy occurrence. For example, a telephone receiver is taken off the hook. A state is the condition of the object at a moment in time between events. So for example, when a telephone is in the state of being idle after the receiver is placed on the hook and until it is taken off the hook, so it will be in a particular state. So that it represents a transition is a relationship between two states that indicates that when an event occurs, the object moves from the prior state to the subsequent state. For example, when the event off hook occurs, transition the telephone from the idle to active state. Now let us see how to apply the state machine diagrams. Object can be classified into state independent objects and state dependent objects. State independent objects. If an object always responds to the same way to an event, then it is considered state independent or modeless with respect to that event. The object is state independent with respect to that message. Now let's see about state dependent object. The state dependent objects react differently to events depending on their state or mode. State machines are applied in two ways: to model the behavior of a complex reactive object in response to events, to model the legal sequences of operations, protocol or language specifications. A state allows the nesting to contain the substates. A substate inherits the transitions of its superstate, that is the enclosing state. It may be graphically shown by nesting them in a superstate box. For example, when a transition to the active state occurs, creation and transition into the playing dial tone substate occurs. No matter when the substate the object is in, if the on-hook event related to the active superstate occurs, a transition to the idle state occurs. So this is an example related to the telephone call. So we will have a substate called playing dial tone here. So that is given this diagram. This is another example of coffee vending machine, state diagram for coffee vending machine. So we have the states on state, power on state, that is a start state, and final state is the power off state. Then it has states, various states like S1, S2, S3, S4, S5 or the states. That is ideal state. First one is ideal state, second one is waiting for coins or to display the amount entered, then waiting for collection, okay, selection of what drink we are going to have, and next one is dispensing. Next state is dispensing, and the final state is refunding change. If we have any change, we are going to give it back to the customer. So that is the states. Now let us see when to use the state diagram. The state chart diagram describes the flow of control from one state to another state. States are defined as a condition in which an object exists and it changes when some event is triggered. The most important purpose of state chart diagram is to model the lifetime of an object from creation to termination. The state chart diagrams are also used to forward and reverse engineering of a system. However, the main purpose is to model the reactive system. The main usage can be described as to model the object states of a system, to model the reactive system. The reactive system consists of reactive objects, to identify the events responsible for state changes, forward and reverse engineering. Thank you.